Hey, I'm the automation engineer and this is my kitchen. Now I'm going to explain you how asynchronous programming works. But first, let's make a cup of tea. See, making tea is not that complicated. There are 4 tasks involved in making tea. Boil the water, wash the cup, put the tea in the cup, and pour hot water. So let's do it synchronously. First, I boil the water, which means I will need some water. And we wait. The water is ready. Now the second step is to wash the cup. So now I'm gonna wash it and come back. Done. So the third step is to actually get the tea and put it inside the cup. And the fourth step is to add some water. Here you go. Okay. Now that's some really nice peach flavored tea. But you might have noticed something. It took me around 2 minutes and 56 seconds to make this thing. And I could have done it in less time. Now let's do the same thing in an asynchronous manner, which means I will be doing multiple things at the same time. Here I'm back at step 1. I have my empty kettle, dirty cup, and a box of tea. Now let's boil the water first, as it's the first step. Now that I'm working asynchronously, I don't have to wait for it to be complete before moving to my next task, which means washing the cup. So I'm going to wash the cup while the water is boiling. And I said we don't have to wait for it to boil. So now I'm going to put the tea on it and add the water. There is a little problem though. That tea doesn't look as good as the previous one because I didn't actually wait until the kettle stops. What I've done is called a race condition. Now, what is a race condition really? A race condition is a problem that we face when one of the tasks depend on another task to be complete. In this case, I poured the water while the water was still boiling. What I should have done instead is to wait until the water is completely boiled and then do the pouring. See, asynchronous programming can save you some time, but it can also cause you some problems. So you have to be wise while using it. Here I have 3 scenarios visualized. The first scenario is where we do everything synchronously, where we boil the water, wash the cup, put tea in the cup, pour water on tea, one by one. Now the second one is the race condition, which is the wrong one. And third one is the proper way, which is we wait for the water to boil. First, I imported time and threading module. Threading will help us do the asynchronous part. Time will help us measure how long it took for the process to be complete. I have 4 methods here, which is the exact 4 steps we did in the video: boiling the water, washing the cup, putting tea in the cup, and pouring water to the cup. Now, here at the bottom, inside if name main block, right here, I will write some code and I will measure the performance of it. So now let's simulate the first scenario where I do everything synchronously, which means I boil water, wash the cup, put tea in the cup, and pour water to the cup. Let's run that and see how long it takes. Okay, it took around 10 seconds, a little bit more, but the order is completely correct, which means everything makes sense. First we boil the water, then we wash the cup, then we put tea, etc. Now let's try to do it asynchronously, but in a bad way, like I showed in the video. Make sure you've imported threading at the top, and here I will delete those 4 methods and replace them with threads. A thread is basically a task that we can perform in parallel to the other tasks, just like these 4 methods that I've defined here. Each of these things can be a separate thread. So let's create thread 1, which equals threading.thread target boiled water, and make sure you don't put parentheses after the method, because we don't want to call the method, we want to give the name of the method to the target. Now thread 2 equals threading.thread target equals wash the cup. Thread 3 equals, I'll just copy it, paste it, change the name, which is put tea in the cup, and copy, paste, thread 4, and pour water to the cup. Okay, now we have a thread from each method, which means we can run all of them asynchronously. Let's run it and see how it looks. But before we run it, we need to actually start the threads. So thread 1 dot start, copy, paste, and do it for all 4. Okay, start means that start doing your task if you come across something that doesn't need your attention, such as the time.sleep here. Do the other task in the meantime instead of waiting. So that's what it's going to do. It will start boiling the water, and when we are waiting for the water to boil, the CPU will actually switch to the next task, which is thread 2.start, and thread 3.start, and thread 4.start, etc. Let's see how it looks when we run it this way. Okay, now it says completed in 0.0003 seconds, which seems wrong. And after that, the water is boiled. So you know what it did? It started boiling the water, and immediately after that started washing the cup, put some tea in the cup, poured water to the cup, but it did all of that before the water is boiled. So this is fast, but it's wrong. What we need to do is wait until the water is already boiled before pouring it to the cup. So here's how we can do it. Now in the first step, we start boiling the water, which is okay. The second step, we start washing the cup, which is still okay. The third step, putting tea in the cup, which is again okay. But the fourth step, pouring water to the cup, depends on first step to be complete. That's the important part. It depends on it, which means we need to wait for the first thread to finish execution before starting the last one. So here I'll put thread1.join, which means wait until you're complete, and then after do the thread 4. Now let's run that and see how it looks. And it took around 10 seconds again. But this time, as you can see, while the water is boiling, the computer was also washing the cup, and the cup is washed while the water is still boiling in the background, which means it did what we want. So that's how you prevent a race condition. Tastes like hot water with slight flavor. Yeah, I definitely should have waited for the kettle. Okay, this video took actually longer than I expected because I actually did it in multiple takes. I hope it's gonna turn out to be good. I hope it will turn out to be good. I hope. Yeah. Thanks for watching.